It might help if you draw a quick sketch of what's going on. So the ball is at rest at the top. We drop it, and for 3 seconds it's covered this distance. And then it goes another 7 seconds. It's going further, it's done a greater distance. Now we want the next 7 seconds. So if it's gone 3 seconds and then another 7, it's done 10 in total. We only want this distance here. And to calculate that, we're going to have to work out how far it fell in 10 seconds, and then subtract the distance it did in 3 seconds, which are given. We're told that's 45. No calculation required there. So we've got the frameworks of a plan of what we can do here. Now we're given a proportion, which we need to convert into an equation. Let's write out what the proportion is telling us, and that's that d is proportional to t squared. To convert a proportion into an equation, we can just replace this with equals k. So d is equal to k times t squared, where k is a constant which we need to find out. Just to show that this is the case, but if I had that d was proportional to t, let's simplify that down a bit. Now if I double d, I double t, and if I half t, I'm halving d. That's basically what this is telling me. No matter what number I put in front of t, so if I have d is equal to 2t, that's still the case. If I double either of these, it has the same effect on the other. I can divide by 3, that's still the case. I can times that by 5, it's still the case. You get the idea. Whatever I do here, if I'm either timesing or dividing, then that's going to give me the same proportion. Now k could be fractional, or it could be an integer. So whatever we times by, that's fine. Dividing by 3, that's basically the same as timesing by a third. But as soon as I add 1, if you were to do this into a calculator and put some values in, you'd see that it's no longer directly proportional. It works the same with this over here, but when we have it proportional to t squared, if I just times the t squared by k, whether k is a fractional value or a whole value, then that's fine, we've still kept the proportion. To work out k, we need to rearrange this formula, and we get that k is equal to d divided by t squared. From k's perspective, it's being times by t squared, so we want to do the opposite, which is dividing. And now we can just substitute in some of the numbers which were given. So we're given that it fell 45 meters in 3 seconds. So 45 divided by 9, that's equal to 5. So our equation must be that d is equal to 5t squared. And now we can just substitute in 10. We have 5 lots of 10 squared, because that's what we're trying to work out, how far it fell in 10 seconds. We get 500. Now we worked out 500 as the distance it fell. Let's just mark this on our diagram so we can just visually see what's going on. So we fell a distance of 500 at this point. We fell a distance of 45 at this point, and we're trying to work out this distance here. So if we did 500 minus 45, that gives us 455 meters.